In this video, I want to look at how to multiply and divide fractions, and then give a brief introduction to how to expand this to rational expressions, fractions that have variables in either the numerator or denominator. Let's start with multiplying. The rule for multiplying says a over b times c over d is equal to ac over bd. So what this tells me is I should multiply the top and multiply the bottom. So let's look at some examples. 3 over 4 times 7 over 9. I can multiply the top. 3 times 7 is 21. Multiply the bottom. 4 times 9 is 36. And then we can reduce. There's a 3 in common here, so I can divide both the top and the bottom by 3. And that would give me 7 over 12. So there's my final answer. Alternatively, doing 3 over 4 times 7 over 9, we can simplify first. When we simplify fractions, we need to simplify over the top and the bottom. We can see that the 3 and the 9 have a 3 in common. That would turn the 3 into a 1 and the 9 into a 3. 1 times 7 is 7. 4 times 3 is 12. So we can simplify either before our multiplication or after. Let's look at a few more. Let's look at 2 over 3 times 15 over 16. Let's start by multiplying. 2 times 15 is 30. And then 3 times 16 is 48. And then we can see that these do have something in common. In fact, they have a 6 in common. Dividing the top by 6 gives me 5. Dividing the bottom by 6 gives me 8. So my solution would be 5/8. On the other hand, let's suppose we want to simplify first. We need to cancel over the top and the bottom. The 2 and the 16 have a 2 in common. The 3 and the 15 have a 3 in common. That leaves me with a 1 and a 5. 1 times 5 is 5. 1 times 8 is 8. So either one of these is going to be an acceptable method. Now let's look at dividing fractions. A over b divided by c over d is equal to a over b times d over c. We take the second fraction, we flip it, and then we multiply. So let's look at some examples of this. Let's do 9/4 divided by 3/10. So to divide, we take the second fraction, the one we're dividing by, we flip it, and then we multiply. 9 times 10 is 90. 4 times 3 is 12. Once again, these have a 6 in common. I can divide both the top and the bottom by 6. When I do, 90 divided by 6 is 15. 12 divided by 6 is 2. Alternatively, when I flip the second fraction and multiply, we could simplify first. A 3 and a 9 have a 3 in common. 9 divided by 3 is 3. 3 divided by 3 is 1. A 4 and a 10 have a 2 in common. 4 divided by 2 is 2. 10 divided by 2 is 5. 3 times 5 is 15. 2 times 1 is 2. So both of these would be acceptable methods to dividing these two fractions. Now let's look at 6 over 4 divided by 2/3. The first fraction stays the same, and we flip the second fraction. 6 times 3 is 18. 4 times 2 is 8. We can see these have a 2 in common, so I can divide the top and the bottom by 2. 18 divided by 2 is 9. 8 divided by 2 is 4, so the answer would be 9 over 4. If we wanted to simplify first, 6 over 4 times 3 over 2, well, we can see the 6 and the 2 have something in common. 6 divided by 2 is 3. 2 divided by 2 is 1. And now nothing on the top has anything in common with anything on the bottom. 3 times 3 is 9. 4 times 1 is 4. Let's very briefly look at expanding this idea to rational expressions, things that involve an x. And when we're dealing with these, it'll be really helpful to cancel first, to simplify first. We're looking for things that are the same on the top and the bottom. And we need to be multiplying them. This is why I have everything factored. We can see right now, we have an x plus 3 on both the top and the bottom. We have an x minus 1 on the top and on the bottom. And we have an x plus 2 on the top and on the bottom. So what we're left with, the top has an x plus 7, the bottom has an x plus 4. And so this right here would be our solution. We cannot simplify any more than this. A lot of people want to cancel the x's, but that cannot be done. We can only cancel when we're multiplying. We cannot cancel over addition.